Hi, my name is Dan. I'm from a company called Paperspace, which is a serverless AI platform built for developers. Don't worry, I will unpack what that means in a bit. But before we dive in, just a quick note on what I'll be discussing today. As someone who's been in the trenches working closely with companies in the space, I thought it would be interesting to discuss some of the common pitfalls or challenges that companies are up against and sort of how we're responding to them. And then I'll wrap up with some brief remarks on some trends or broader industry shifts that we're starting to see emerge that we think are important as this technology begins to mature. So really quickly, what do we do? Paperspace is a platform where companies develop and train deep learning models. What does that mean? Really, there are kind of two primary pieces involved. The first is infrastructure automation. So today, as you probably know, infrastructure is one of the biggest bottlenecks in deep learning. And so how do you eliminate that? By abstracting infrastructure away entirely. And then there's this sort of software layer on top of that. And an analogy that is often used to describe this kind of layer in the stack is the GitHub for deep learning. Why the emphasis on deep learning and not data science or even ML? Our fundamental belief is that these worlds do share a lot in common, but in practice, they are more different than people tend to think. I'm not going to dive too deep into this distinction, but to disambiguate a bit, the thing that separates these two worlds for us is really quite simple. Are GPUs involved or not? Companies that are doing modern deep learning today need GPUs, lots of them. So much so that they need to offload compute to the cloud because training can take days or even weeks on local systems. The reality is deep learning has a compute constraint that creates a real orchestration nightmare that just didn't exist previously. And that's something we spend a lot of time working to solve. So with the advent of deep learning, you have this entirely new class of users onboarding to the cloud for the first time. So for us, this poses a really interesting opportunity to take a step back and rethink how these people should interact with the cloud and what tools they should be using. And here's why this matters. From talking to our customers, we've noticed something pretty alarming. AI developers are spending roughly 3/4 of their time thinking about infrastructure and only about 1/4 of their time doing the thing that they're essentially hired to do. These are some of the most sought-after people in the tech industry, or really any industry for that matter, and very little of their time is actually spent developing models. These are PhDs, people with incredible expertise in stats, low-level math, neural networks, TensorFlow, and they're spending time thinking about Kubernetes, how to queue jobs up, how to access Jupyter or TensorBoard on a GPU cluster. It's really an inefficiency of kind of epic proportions. So what is the underlying problem? It really comes down to one thing. The cloud, as we know it today, was built for the singular use case of deploying and managing web servers. Cloud products are made for DevOps, and DevOps as an audience have almost nothing in common with a typical deep learning practitioner. If you think about where DevOps are in the stack, they're here, and your AI developers are up here, or should be up here. Yet somehow the default assumption is often that the deep learning person you just hired needs to figure out a tool that was not even designed for them. On top of the public cloud, we have a very rich ecosystem that developers can plug into. Tools like GitHub, Docker, CircleCI, New Relic. These tools abstract raw infrastructure into something that development teams can operationalize. The thing that's, of course, missing from this picture is the equivalent for AI developers. So how do you solve this? Getting this right is tricky. On the one side of the spectrum, you have these sort of toy projects where you can tinker with a neural network and a web interface or GUI. And then on the other end, you have these really low-level libraries, things like Kubernetes, that really belong more in the world of DevOps and not development. The issue is that unlike software development, where you can sort of pass off your code to your DevOps team to deploy, these folks actually need to interact with the cloud in a more real-time way. And when thinking about the problem as it exists today, you really need to figure out how to balance that effortlessness with flexibility, and that means finding the right sort of layer of abstraction or right level of abstraction. Luckily for us, there's precedent for this. The big tech companies have been thinking about this problem a lot. So much so that they've actually sort of home-rolled or created their own tools to solve this exact problem from scratch. So our job is easy. It's really to sort of like make a plug-and-play version of this tool available to every company so that any company can have the power of these large tech companies at their fingertips. And that's really it. That's what we do. As I'm sure you know, deploying a web app in 2018 is quite trivial. It's very easy. So at a high level, our goal as a company is to make CloudML as easy as deploying a modern web service. So what does a typical, or what does a platform for modern deep learning look like? Theoretically speaking, you have the sort of basic components of the pipeline. You have data ingest, training, model analysis, and deployment. And specifically, you have fully managed GPU infrastructure. We actually run our own cloud and can also run in other environments as well. More on that in a bit. We have provide a unified dev experience via the command line and UI. There's a sort of centralized place to view all of your jobs, including the code that was run, the container, the framework that was used, any metrics that you graphed, and so forth. We have an integration with Jupyter, full API and language integrations with a heavy focus on Python. And then you kind of have the SaaS layer on top, which is super important. It's things like ACL, team controls, collaboration tools, sharing, productivity, everything that you'd expect from a plug-and-play solution. Below that, we have Gray, so the workhorse. So Gray is an orchestration framework. It's the plumbing that, the sort of plumbing layer that does all the hard stuff that AI developers should not be thinking about. Things like job queuing, container management, logging, et cetera. One of the things that Gray does really well is make running on heterogeneous hardware not only possible, but effortless. So Gray now includes, as of about a month ago, support for the TPU, which we're obviously very excited about. Going back to this problem of abstraction, we've co-opted the serverless idea because it allows developers to think about GPUs or TPUs or really any other accelerated architecture as a single line of code. I know the serverless analogy is a bit of a stretch, but what company doesn't have their extremely vague one-liner? Anyways, we think it works. So zooming out, this is the sort of deep learning pipeline of the future. It's a little bit hard to read, I apologize. So on the one side, you have your data lake, data warehouse, or kind of real-time data stream coming in. Then from that, you create your feature store of training data that can get fed directly into TensorFlow, PyTorch, or any other framework. Then, of course, you develop and train models in parallel, iteratively. And then, of course, there's this evaluation step where you evaluate the results of these models, and then ultimately you deploy. Deployment can happen as a RESTful microservice or on an iPhone. The key is this last step is much more akin to traditional web deployments. So before we wrap up, just wanted to close with a few remarks on some of the forward-looking trends that we're seeing in the industry. So first is the insane amount of money or investment pouring into AI chips. Cerebras, GraphCore, Nirvana, Grok, Vathis, TPU, and many more. One of these is actually valued at $1 billion already, has never even shipped a product. As we all know, the GPU was a really nice hack to accelerate training, but there are some serious limitations, such as 25 years of R&D and things like physics engines and cinematic rendering that have basically nothing to do with the task at hand. So there's no doubt that a specialized chip can lead to some serious performance gains, and we're very bullish on these chip makers. But the problem still remains. Running on these esoteric chips is not trivial. The first thing you learn about the TPU is that it's a network device, not a PCI device. So your pipeline will break trying to access it. And then what happens if your data happens to live in AWS or on-prem? How do you get data into the TPU? I could go on and on, but the point is, these are the kinds of problems that we can solve once for every company. The bottom line is, if you want to leverage these chips because they offer 1,000x speed up, you need a front end, something that can connect the different pieces together without reworking your entire process. The other interesting thing that we've seen play out over the last few years is a really interesting evolution underway with respect to deep learning in practice. A few years ago, people were obsessed with this idea of that everything should be an API, that there would be an image recognition API, a NLP API, the recommender API. This is an example of trying to shove deep learning into that web services model. And so, as we all know, there are many serious limitations to this, and the end result is that it just doesn't really work in practice. In a lot of cases, it does in some cases. And then everyone thought we could just refit models into pre-trained models. But just like using a generic API, simply put, if the problem statement is different from the one on which the pre-trained model was trained, the prediction will not be accurate. And so what people are realizing is that AI is so core to what they do that they can actually benefit from owning the model. It becomes IP in a very powerful way. And these companies are now hiring these AI engineers to develop their own proprietary models, and this is clearly the way forward. And lastly, as deep learning somewhat matures, we're just now beginning to see best practices emerge. So we've gone from the last few years from multi-GPU to distributed deep learning. Containerization has finally arrived. Hooray. Jupyter has become the IDE, and generally there's a consensus around this idea of a job architecture. With this in mind, I just want to end on a key point. Many of the existing DL pipeline tools are extremely heavy-handed in their approach. Architecturally, they'll support one framework or maybe even one specific version of TensorFlow. And they care a lot about what format your data is in, where your compute runs, how you do hyperparameter suits, things like that. And if anything in your workflow is incompatible with how these systems are designed, you're sort of dead in the water. And on the contrary, we try to be as hands-off as possible. For example, one thing you might be wondering is what our relationship to Spark looks like. The answer is we don't have one because we don't need to. Spark just works out of the box. We're very careful not to be opinionated about what framework you use or where your data lives, where your compute runs, and so forth, because it's still early days. And getting back to that earlier point of finding that right layer of abstraction, you need to be careful you have a system that is designed from the ground up with flexibility at its core. So yeah, I guess just wrapping up, at the end of the day, you just need to remember one thing, that it's still early days. In the last 5 years, we've gone from essentially 0 to self-driving cars and bots that are indistinguishable from humans. We've accomplished so much, but AI has achieved maybe 1% of its potential. The tools and workflows are in their infancy and will continue to evolve over time. So this is why it's such an exciting industry to be a part of. And with that, we'll wrap up. Happy to geek out with anyone later over beers. You can reach me directly at daniel@paperspace.com. Thanks.